Hey, welcome back to Fat Mama Physics. Here we have some more examples on momentum, starting with example 3, which I will do, and you will do example 4. All right, let's get started. A 0.5 kilogram water balloon is thrown against a wall at 32 meters per second, and it comes to a stop. Ooh, it comes to a stop. What is its change in momentum? Okay, we're starting to do some other things now. First of all, we want to know, what does change in momentum mean? Okay, whenever you see the word change in physics, even in chemistry, etc., it's always talking about the final property of something minus the initial property of something in whatever state it was. So here it would be the final momentum minus the initial momentum. So we do have and we know, since momentum is mass times velocity, the mass is not going to change in this water balloon. The only thing that will change is its velocity. So we know that the balloon starts off with 32 meters per second. So I'm going to use a U for initial velocity from your data booklet. And coming to a stop, we know that's a velocity of 0. So our final velocity here is 0. So let's put this into our equation. So let's write it out, in which here my change of momentum is going to be mv for final and minus mu for initial. Putting all my values in here, I get, and then putting into our calculator. And you're right, I could just have done mass times the change in velocity instead. So I get negative 16. So this negative 16, it just shows that my change in momentum is in the opposite direction relative to the balloon that it was going at. And this particular question doesn't mention a direction for the water balloon. So if I'm just assuming the 32 meters per second was traveling in the positive direction, and the opposing change in momentum in the opposite direction, the negative sign here is enough, okay? So 16 kilograms times meters per second. You might be wondering, what's the significance of the negative sign, and what is change in momentum? Why do we care about change in momentum? It's just a random number that has a value with a sign. I want you to think of it as this. Remember, we talked about in the first video whether the elephant or the bird was harder to stop? Let's apply that to this water balloon. If the water balloon was traveling in this direction with 32 meters per second, and you had to stop it with your hand, for example, okay? If you were to stop this water balloon moving towards your hand, in which direction would you be applying a force? If you're thinking if you have to apply a force in the opposite direction, you are correct. And that's where this change in momentum business is going to go towards. We're going to later associate this change in momentum with a force. Not in this lesson, but we're just doing the calculations just so you get used to it. So let's see what happens next, okay? Now we have a 0.5 kilogram bouncy ball instead. Oh, it's also thrown at 32 meters per second, but it bounces back with the same speed. Okay, is it thrown against the wall? Yes, it's thrown against the wall. How does its change in momentum compare with that of the water balloon? Ooh, interesting. So let's draw a picture to illustrate what this means. Imagine you have a wall. Sorry, not a hand. It was a wall. I forgot. Okay, so you have a bouncy ball that's going towards the wall at 32 meters per second, and then is going to bounce backwards with exactly the same speed, but in opposite in direction. So we're going to have to label some directions here. I'm going to label towards the wall as the positive direction. So this bouncy ball's initial speed is positive 32 meters, whereas if it's going backwards, its final speed is going to be final velocity is going to be negative 32 meters per second. So now we have the speeds, we have the mass, we want to find the change in momentum again. And since the mass of my bouncy ball is not changing, I can simply write this as mass times the change in velocity here. if I simplify that, that's going to be final velocity minus initial velocity. Let's put our values in. Okay, so here we have our values. A common mistake students will make in this problem is instead of using minus for 32 meters per second for the final velocity, they use a positive value, thinking, oh, it's the same speed. But remember, we're talking about momentum in which direction matters, and the positives and negatives matter as well. So what they would have done, they would have put a positive sign here, positive 32 meters per second, and again, a total change in momentum is 0. That's incorrect. Please don't forget the directions. So putting this into my calculator, I get negative 32, which is definitely not 0, okay? So kilograms times meters per second. Notice this value is twice or double the value you got in the previous question, which the object just stuck to the wall. And if you want to put this, let's put this in context with, say, a hand, okay? Instead, your hand was stopping this bouncy ball, all right, coming towards you at 32 meters per second. Is it easier to stop the bouncy ball if it just collapses in your hand? Or is it harder to stop the bouncy ball if it also had to bounce back? Think about how much force it would require you. With a larger change in momentum, the force applied to this ball had to be larger in order for that to happen, okay? So that's what this change in momentum is about. Again, don't forget directions and don't forget your positives and negatives, which means you can use that in example 4. We have a 1 kilogram ball hits the floor with a velocity of 2 meters per second. If the ball bounces up with a velocity of 1.6 meters per second, what is the ball's change in momentum? Okay, so a very similar case, but now you have a ball that is coming down at 2 meters per second and then bouncing back up with a slightly less speed, but opposite in direction, 1.6 meters per second, okay? So good time right now to pause the video to try this problem out. Okay, now I'm going to do the solutions on fast play. We're going to set the downwards direction to be positive, which means the 1.6 meters per second going back up will be a negative value when we put in the velocity here, so that the mass times the change in velocity, we get negative 1.6 meters per second minus the positive 2 meters per second. Okay, so I get a total value of negative 3.6 kilograms times meters per second, or you can write 3.6 kilograms times meters per second back up again, because I've chosen the downwards direction to be my positive direction here. Again, don't forget to put in a negative sign for the 1.6 meters per second, because it opposes the original direction of velocity there. Okay, so that is change in momentum. We will need this concept when we talk about the next lesson, which is on impulse. I thank you for watching this video with me. Hopefully you have learned something that you can apply to your own examples and practices. Good luck. Fat Mama Physics, signing out.